Can you guys hear me?
Yeah, good evening, sir. How are you doing?
I'm
Yeah,
good.
good
I'm good.
evening.
I'm good. Good evening. First, I'd like to apologize for not being able to make it yesterday. So yeah, let's start because of time. All right. So we already spoke about the PM tools and Stack, and we learned a lot about this. Why is it private? Okay. So we already spoke about the PM tool and Stack. We spoke about front end and mobile as well. So we know what that is right now. So today we'll be learning about backend. Right? We spoke extensively on what front end really looks like. Why do we even call it front end in the first place? And if you missed that class, you can always go back to it. All right, today we'll be learning what backend is, right? What exactly is backend, and how does it concern me, right, as a product manager, and then what is SQL, right? So let me start by saying that SQL is, the way we spoke about HTML and CSS, spoke about HTML that it provides structure for your website or your platform. We spoke about CSS that it allows you to style it, like give it color, and all of that. And then we spoke about JavaScript, that this basically adds interactions to your website. So things like animation, things like you want something to dance, and all of that. Now, for the backend, we have a language as well that like this part of the backend understands. The part of the backend that keeps your data is called a database, right? Is that part of the backend where your data is kept and can be easily retrieved. So you can consider, when you think of an example of what a database is, you can think of it like I would have said your normal colo where you put money, but you can think of it like your ATM machine, right? You can put things inside, and if you have the right card, the right pin, and everything, you can also like take out the money, right? At least, and even now, right? I don't know if some of us have used that ATM before. I know GT Bank now has it in some of their branches, but like you can basically go and deposit money through an ATM machine, right? This kind of what do I call it? Think of this like that for the database. So when you think of a database, it doesn't just save data, it also has the capability to give you back the data. However, what language is used to actually talk to the database? This language is one of the languages is called the SQL. Um, there time will not permit me. I would have spoken a lot on database. But just to give you context, there are different type of database. Just like you have different type of ATM. I have used at least maybe three different type. I've used the regular ATM machine where you put in your card, and I've used the same machine where you use your fingerprint. I don't know if anyone one of us have used it as well. I used it in GTB as well, where you just put your fingerprint and then it asks you certain information and then you put it in. That's all, right? And I've heard of those that basically use Face ID and voice. The point is, even though all of them are database, because of the features or the way they are built, their input will be different. Sometimes the language might also be different. So there are different type of database, but the major classification that you would find when your developers are talking or when you're making decision is in two formats. You have the structured database, and then we call it no SQL, basically no structured database. Now, structured database in the sense that structured database takes the shape of like a table. So which means there is a column and a row, like there are rows in a column. So the way your table looks, where every single row in a table is a record. Imagine you have a table that has the list of students in SS1, for example, right? That table will probably have different columns, and these different columns can be, column 1 can be the matric number, column 2 can be first name, column 3 can be last name, column 4 can be the class they belong to, column 5 can be the department, column 6 can be the course they registered, right? But every single role on that table will always be a record. We can call it a record or a tuple, right? I don't want to go into technicality, right? But in a nutshell, we have these two types basically of database, and at least major one. Of course, there might be more now, but the top ones, if I will not be going too deep, is you have those two. The first one, like I said, follows a structured approach. That means there's rows and column, and because it is guided, which means it is structured, every of the record follows the same pattern. You can't put name for record 1. Let's assume the 4 of us are students, right? I can't put innocent name in column 1, and then when I get to Joseph's record, I go and put maybe his age. I'll give you an example. Let me go to sheets.google, sheets.new. All right, so let's assume this is a record. I have full name, age, and let's say gender, right? This is a simple table. Now, let's assume I want to put this information for those of us on the call. Again, I don't want to assume, let's assume I am female. I don't want to use anybody for example. So I'm saying this is Michael Oluyomi. Let's say I'm 12 years old and I am female, right? I would expect in a structured manner that if I want to write about innocence, let's say, Hugo, here as well would be probably innocent age. If I come here and do male and 12, right, there'll be a problem. Why? Because there's an expected format that data should be presented in this particular sheet. Because I already defined what the data should be presented, that every column is this format and the other column is that format and the other column is that. So if I put the data of this column inside another column, then there will be a problem at the end of the day. So this is what we call structured database. So it's structured because we have a structure for how the data should be saved. However, recently we have no SQL. That means there's no structure. I can decide to put my data exactly this way, right? The language can actually know exactly what I mean when it comes to this particular Michael Oluyomi. Again, like I said, I might not be able to go into details, but just understand on the surface that there are two major types, the structured one and the NoSQL. Top systems like top companies would probably go for structured database because it makes life easy, and then it's easy to query. SQL has been around for a while, so you have a lot of people that uses it and all of that. And in some cases, NoSQL can be found in cases where the data is very huge and you don't have time to be following a structured approach, right? Or your database, again, performance-wise, you don't want to have to be going through a lot of queries to get things to do. Very soon you will understand why. So in such case, for example, in the case of chat history, those things can be saved in a no structured environment, or analytics data, right? Because it makes the query to get them faster. NoSQLs are sometimes a bit faster based on what I've heard. All right, I don't write code, you don't write code, but the reason why we learn them is so that we can actually contribute in conversations that involves technical stuff, right? That's why we learn them. All right, so in the language of SQL, there are certain keywords that you should probably keep in mind. So when you see a query, I'll explain some of the things that most queries that you find, right? They probably border around these major ones, right? So select means that you are saying, okay, which of these columns or which of these rows, so to say, am I trying to get the data from, right? That's what select is. From is which table. So I'm saying that get, for example, name from which table? From the user table, right? And then join it. Join means I want to now join one table with another one. Let's assume we have a user table that has the information about admission, right? All the students that we admitted, like, why we admitted them and all of that. There's a record for it. And then there's another record in the department for all the students that actually graduated. Now, these are two different records. As a matter of fact, probably two different systems are using the different records. However, let's say I want to query the database to get information about students that were, for example, that were admitted but did not graduate. So instead of me going to look at it individually, I can do a join when I'm trying to make the query. So I'll say, okay, because usually the student that were admitted, their matric number would always be the same as those that graduated. It's not like when they are in 200 level, their matric number will change, right? It's always be the same. Or there are certain number as well, like their JAM registration number. There are things that you can actually use to join them together. When you are joining, usually we join with the primary key of the first. Again, I don't want to go through detail. Just know it on the surface. You are joining table 1 to table 2 so that you can actually analyze them and make sense of data from them. So, like I said, select name from which table? From maybe table admission, list of people that we give admission to. And then you now join it, right, to list of students that graduated, right? Now, where clause is used, for example, which of this row should I actually send back to you? You can now say where maybe the column, where the column can be something like the column can be, okay, so for the query that we want to write right now that I'm talking about, so you are saying that select admission table, that means the table that has all the admissions of the student from, select the name. You can select multiple things. So you can say select the name, address, email, and phone number of, select these three variables, these three columns from which table? From the table of all the students that we've admitted. I've explained what join is. Then, because you don't just want all the people that you admitted, you want only those that probably did not graduate. You now say join. Join with what? Join with table of all the students that actually graduated. You now say where the role says not graduated. Do you understand? Something like that. Or maybe where the graduation date is null, right? Or where it could be anything. So that way, when the system makes that query, it joins the two tables together and it gives you back the response of those that doesn't have a graduation date, right? So this is just basically what SQL is. It's like this code that allows us to actually inquire from the database or send data to the database. We have quite a number of them. Group by as well. We also have group by. Say you want to know, you want to group the rows. For example, remember I said that the rows are the records in a database. So every single line in a row, I showed you an example when I went to the Google Sheets. Every single row here, right, is a record. So let's say you want to group all of these record by something, right? So you want to add another column programmatically called group by gender, for example, right? So you can group all of them by gender. right? So only those that are male would actually be delivered to you on a group, and then those that are female will be delivered to you on a group. You can also group by age less than X or Y. This language that we call SQL makes it really easy for us to interact with the data that we've saved in the database. Where is it? Okay. The data that we've saved in the database, right? The having term is also used for filtering. So you can say, okay, having which particular group, having blah, blah. Then order is like you're sorting it from, you can say, okay, in alphabetical order or in ascending or descending order. I want sorted by, for example, their age. I want those that are oldest to come first, and then those that are younger should come later, right? And then you can limit the number of results you want to see. Limit is very, very important. And I will tell you where this is very, very important. If you have your developers that they are trying to probably do, maybe there's an incident and they are trying to do something on the database, maybe query the database for one or two things, which should not be happening. But let's say they are trying to query a live database and you are there, right? If they want to send the query, always ensure that their query has a limit in it. Like at least they should limit it maybe to 100 results or 200 results. Why is this very important? Because if the database they are trying to query is very huge, this query, we call it transaction. Every query that you make is called a transaction in the DB. This transaction can take a long time, and if you are not careful, it can cause a deadlock. What is deadlock? Deadlock is a scenario where, um, very good example. Some of us have experienced it before. You, innocent, because you have money, low, and me, I don't have money. I want to go and withdraw my last card. Gen Z will never be able to experience this thing. But when we were in school, we experienced it. We will queue in front of ATM machine. Now there's POS everywhere. But then you queue in front of ATM, especially a day like today, which is when salary have dropped. By the way, salary now, innocent. Everybody, please send tight, right? Send tight to my accounts. I saw that the entire Lagos is blocked. All of you collect salary, you went home early. Anyway, back to class. All right, so in those days before POS became a thing where you have to go and withdraw to pay for everything, right? Yes, the salary came on a Friday. Everybody's shouting again now today. Anyway, you will have to queue. Like you go to the POS. In fact, for banks like GT Bank that used to have like maybe 7 POS stand, if you go there, there will be queue on all the 7. And then finally, it's just one person to your turn. Then everybody has been withdrawing money since morning. You have been coming from the back, and your mind is telling you that the money in this ATM I want to finish, and you just want 2,000 naira. And then someone like Innocent who has just collected salary and he wants to go shopping, he wants to go to buy some things. Is there at the ATM, and then because the ATM does not give all the money at once, it gives 20,000 naira. And then Innocent brought back his bag and put it in front of him like this. And then withdraw the first 20,000. Withdraw the second 20,000. And you are there. Me, I know that we've shouted that kind of shout. But let somebody else withdraw money, Jerry. Are you the only one that have money? Right? In this Nigeria, what happened at that particular point is that there's a deadlock. One person is not able to, everybody is not able to continue what they want to do because one person is actually taking that space. And that's usually what we call a deadlock, right? So depending on the capacity of your system, sometimes when a particular query is taking too much time in your backend, right, it makes everything in your system start hanging. Like everything in your system that requires that database to function will now start, acting up. Ideally, every request to the database should probably happen in less than 0.001 milliseconds in most cases, right? Sometimes highest 1 milliseconds, right? In most cases. But if it's taking 2 minutes, 3 minutes, then you know that every other system is affected. So in this case, that's why I said if you find yourself in a place where maybe there's a problem and you are on a call, usually some people, I've explained what war room is to you. Maybe you are in a war room and your developers are trying to fix something and they say, okay, please let's just go to the DB and check what the data is. And then you notice that the developer is trying to make a query without adding a limit. Always shout, Baba, oh, limit, right? Limit your results by 100. We just want the first 100 results or the last 100 results, or, filter and limit it so that at least, filter can actually run through the entire table as well. And but just limit your results so that it doesn't continue loading forever and ever, right? So this is something that is very, very important to us as product managers. Of course, as you learn about them, it will get better. I would share a place for you guys to learn. If you want to learn more about SQL, you want to practice, there's a website that you can use to learn. So it's here in the material, so you can click on it and just and it's fun. You can learn it for fun. I'll click on it so that you guys can see. All right. So if you learn these three, then things become a bit easy for you. Of course, we have see this particular query now, right? Say I want to get daily active users. You see, select dates. That means select date created at as day, right? And then count distinct user ID. Okay, count is also another key value in SQL, that instead of getting all the results, it just goes through them, count it for you, and give you the answer, right? Also, in most cases, this is also one easy thing that you can use to check if your database, for example, your system is just unnecessarily slow and requests are failing, right? This can be because your database has become very heavy and all that. So one way that you can easily validate, or your developers can easily validate, is just count the number of records that are in that particular table. If it's huge enough, you can do a backup and delete it, make it lighter. Maybe just leave like 3 months old records, especially if you're in B2B, right? And then back up the rest so that at least your system can be faster when it goes to DB to request for data, right? So you have counts a lot. We use count a lot because usually we want the average, right? That's why you're seeing examples here for counts. Of course, I've spoken about what daily active user, adoption rates, retention cohorts. I've told you about retention before, cohorts, and revenue by plan. All right, so I've explained what join is. But let me explain. There are two types of joins. We have the inner join and left join. I think this is not very, very very important to you guys. It's more technical, but I'll just try to at least explain in a simple way. So inner join is like okay. So think of inner join like you are picking two tables together. Inner join is like I'm joining table 1 and table 2, and I want the result of both tables to show up. Left join is that I'm joining the two table, but to get something in it. So in the example I gave the other time, I only want to see users that got admitted and graduated, because there will be some that didn't graduate. So you probably want to do a left join because you don't want all the data. You only want those that actually were employed, were admitted and then graduated. That's left join. Inner join is, Baba, give me everything that is in the two table, right? As long as these columns are concerned and is in the two table, give it to me. Bring it. So any field that does not exist, or any let's say any field that does not exist, it will give it as null. So what do I mean? Let me give you an example. So let's say this is table 1. Innocent is 120 years old. Male, let's say Adiola Navigator. And then say 8, and then say female. And then let's remove this group by gender. Let's pick one more person. Ike. Joseph. Ike. Okay, because I'm not saying everybody's name finished, so I'll just reduce your own. Let's say Ike is 200 something years old, and then this is male. Let's say this is one table. Now let's have another table here that is okay. Let's have ID here. ID can be 1, 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4, 5. Oh. Okay, so let's now do another table. Say another table that has user ID, nationality, and color, for example. So we have the same user ID, right? Or let's just say user ID. Let's use 3 of the user ID, not 4. So I can use the example for you. Nigerian. Wait, oh no, I'm not Nigeria. Who's Nigeria? Canadian citizen. Canadian. Every other person is Nigeria. You and your government will go and be fighting each other. Okay, Nigerian. Let's say I'm white, and then every other person is black. Black. Okay. All right. So this is an example. You have 2 tables here. Say I want to join this table, which is the user table, and you can call this like the nationality table, right? For example, you can call this country. So let's call this the nationality table, and then this is the user table. So if I do inner join of these 2 tables, what will happen is it will bring this guy, right? Bring them here as the result. Then this one that doesn't have results will be null, right? That's inner join. If I do left join, instead of it to show this guy at all, because there's at least one null result, it will not show it at all. So it will only show the ones that are actually valid for the case. So that's how inner join and the left join works in a nutshell, or in a simple example, right? Yes, no checker pattern, blah, blah, blah. Yes, you can also specify that even with the left join, you can also specify that you should keep the null. But again, at the end of the day, it's your decision. All right, so you have quite a number of them. You have sum, what's their average, max. You also have add, subtract, all those plenty things that you can do with SQL. If you want to learn SQL a lot, like how to query a database, you can check on this guy. It's a platform that allows you to learn it. But basically structured SQL, right? It doesn't allow you to learn NoSQL. But yeah, structured SQL, say the one that is actually very structured, which is, again, remember I told you that you have NoSQL and then the SQL. SQLs are basically relational database. So you can learn a lot from this platform. And then as you're learning, you can also practice. There's a practice mode where it has data about, for example, this is the example. It has Meta, like WhatsApp. It has Amazon. They are like database of all of them that you can play around, write queries for them, get results. As you can see, I was playing around this earlier, and so you can play around it in your leisure. It's in the material, so just walk through it. So in a nutshell, the reason why I'm explaining this is because you need to be aware there's something called SQL. So SQL is that language that we actually use to query our database. It's a backend language on its own, right? Now, let's now go to the backend proper. So remember that I was telling you guys about Monolith and microservices earlier. It's more applicable on backend architectures or infrastructures. But now we have it also in the front-end infrastructure. What is Monolith and what is microservices? Monolith is a scenario where everything is built together. A very good example that I can give is most of us use iPhone right now, right? iPhone, you cannot remove the battery, right? You can't remove the battery of one iPhone, at least you cannot remove it yourself. Let's use that example. You cannot remove the battery of one iPhone and then put it in the other iPhone. Like you say, okay, my friend, please, my battery is low. Can you quickly give me your battery and then put it inside? It's not possible. That's an example of a monolith. Everything is built together such that To separate it will be, you have to be an expert to separate things from each other. Microservices, however, is like your phone. In fact, some of us, our iPhones, you can't even remove your SIM. It is eSIM, right? So it's not like you can quickly just remove your SIM and say, oh, my battery is low, let me remove my SIM and put it in another phone. It's not possible because everything, like I said, is compact together. You can't remove your SD card as well, right? But if you are using the Tana phone, right? That's flashlight phone. You can I think there are some flashlight phones that you can even remove the flashlight, right? But you get the point. You can separate them. And by separating them, it means that they can be connected with other systems, other devices, other tools, such that it's not totally dependent on each other. So that's different between it and a microservice. Monolith is the old way of doing things. That's how most of our core banking infrastructures were built. They were built packed together. But the new way of doing things is to build them as microservices so that I can wake up one morning and say I want to shut down one service and it doesn't affect the other, right? So this is the way going forward. So if you want to build a system, for example, you want to build okay, I'll use this example of it's a recent landing page I built yesterday. So you want to build a system. This is one feature, which is anonymous QA. People can drop message anonymously. This is another feature which shows the program. And then this is another feature that allows you to actually request to talk to someone. Right. So these three features, currently it is built as a monolith. Everything is built together. Right. But I can decide if I want to build as a microservice. It means that in the UI, it might look like it's built together, but on the back end, all the components are separate. They have different database, they have this different front end, they have different back end, they just look alike. They look like they are one, but they are totally different tools. I'll give an example of such tools that is actually very, very popular that we use. Where is Instagram? I hope I'm logged in. So I don't like logging in. Okay. So for example, take this Instagram um, board for an example. This is a feature. It's called a field. This is another feature which is called reels. This is also another feature which is called saved reels, right? And this is another feature called photo view. Then all of these now have other feature. This search engine, like the Instagram search engine itself, is a feature, like is a product on its own. There are team that are working on this particular product. They have their own product managers, they have their own engineers, they have their own database, they have everything. Of course, this database can be connected to each other, but they have basically how they connect all of these together. Now, you have other features like, for example, the analytics, the dashboard analytics. So for this analytics, how do I exactly want it to work, right? Amongst other things like that. This is exactly what microservices is. Even though to the user, they are interacting with the same system, but on the back end, remember we're learning about back end. On the back end is actually decomposable, right? So we call that approach minimum I can't remember the name. It's called a minimum something name. Basically, is modular MCP. It's called an MCP. Minimum composable products. Yes, I remember. Minimum composable products, right? It's called and this MCP is different from the other MCP. So just learn it. In case you hear somebody and say, okay, have you ever heard about minimum composable product before? What they are saying is basically microservices. So you are breaking your services into microservices that can communicate to each other via different formats. It can be HTML call, right? HTTP call rather. It can be API calls to API calls. It can be event-based architecture. I already spoke about this in a different class. But yeah, that's the difference between monolith and microservices. Now, why is this very important? If you are building systems that would stand the test of time, it always have to be built as a separatable module every time. For example, if you go to Microsoft, at least I think Microsoft will be the best example that we all know today. If I go to or let me not even go far, right? Google is a very good example. I am on Google and navigate to Gmail products, but it doesn't mean that all of the products are in the same place. They are different individual products built individually, but they can communicate to each other, right? For example, I can be on Microsoft Word in a minute. I think I can do something that can take me, right? I can be on Google Sheets and create form, right? From Google Sheets, I can create form. From Microsoft Word, I can come to Google Sheets to come and create graphs, right? You know, those kind of that is possible because the system itself are not built inside each other. However, they are built to be pluggable to one another, right? Of course, we have a lot of concepts that makes it possible, like S2S, like token generation, and many other things like that, right? But at the end of the day, what you need to understand, because you're not writing code, the rest you will learn on the job, is there are two ways that you can build your backend system. Is either you build everything together or you separate them into composable modules. That means modules that can be plugged. Like you can decide that, okay, this particular module will make it public so that users can actually, people can actually use our API the way Paystack does, right? And then this part, we are not making it public, only us can use it internally, things like that. That kind of discussion, right? We have spoken about API. I just tried to do a refresher here. I spoke about caching yesterday. So I'll probably not go into it again, but I'll explain it in the case of front end, right? The CDN caching is the one that happens on the front end, which I spoke about yesterday. But there's also application caching. So which means I don't want to go. Remember what I said when I started with in the class, where I said, okay, there might be deadlock because one particular what's the name again? One transaction is taking very long. There's a name we call it. Kenel, right? But again, yeah, you guys are making me remember my lecturer. Anyway, there's a particular transaction that basically is taking everybody's attention, right? So because you don't want to go to the database every day or every time, we used to have something. It also works like a database, but it's a temporary database. It's temporal. And in the way it works, it's not like a query. It just sits there in your system so that the data can be accessed anytime, anywhere, right? The query does not have to go back to the database. So we have platforms like that, like Redis, like, for example, we have something we call Kafka, right? Kafka is also something that helps, right? You don't have to go to the database again. Kafka is just there. The event is floating there. You can pick it till the event actually expires. So this application cache is like a temporary storage where you can put. I think the concept is what gave birth to the likes of POS, right? So what if we can store this money in the cloud and people can go and collect the money and then hold the money, right? So that whoever wants to collect money, instead of coming to the bank where the money is, can just go there and they can have access to the money while still collecting it from the bank. You get it? If you don't get it, forget about it. So the way the caching system works, this is a very good. I like the example. It's actually very smart. I'll be using it going forward. So the way the caching system works is the same thing that gave birth to POS, right? Bank is like, hey, there's so much deadlock in bank. People are always queuing and everything. So what is the solution we can do? We're going to build a system that allows people to collect money from bank without necessarily coming to bank. That will reduce the number of people that come to bank. So what do? They say, okay, all you have to do is come to bank once. And then when you come to bank once, you can take all the money that everybody in your street will ever need. Then when you take it, every other person that wants to come to bank again can just come to you directly. That way, it reduces the traffic in my own office, right? The same thing the database is saying when you are using the application cache. The database is saying, I like you. See, I really like all of you. I like the way you come to the database. But people are clouding my environment. You are making the whole database environment to my system is getting hot. So this is what I'm going to do. You guys are going to have something called Redis. And Redis on its own is going to be how do I explain it? This Redis is going to come and collect big money. And then when it collects the big money, if you need it, you can always go to Redis and collect it before the money expire. And what does expire mean? Before it finishes in Redis hand, right? It doesn't finish in Redis hand, but the concept is it expires in that case. But in this case of money, it actually finishes. And when it finishes, it has to go back again to the bank to collect another one. The same way when it expires on the Redis has to, make when your system tries to collect money and it's not there, your system will have to go to the bank, basically go to the database, collect it again, keep it in the Redis, and then continues like that, so that you don't overheat your system. I explained authentication and authorization when we were talking about API, so I will also not go through it as well. I've also explained event-driven architecture when I was talking about Kafka and then message queue. So think of message queue like this. You want to send a campaign. Let's assume federal government wants to send a campaign to every single Nigerian, right? They want to send a message to every single Nigerian that, hey, there's a lockdown. Everybody sit down in your house. That's a campaign. By the way, I'm hoping that I can actually build a system like that for Nigeria where the government can actually utilize their data to send messages to us. Right? But again, hopefully very soon, the system will be ready. So they send message to all Nigerians. WhatsApp message. Hey, dear Nigeria, this is the Nigerian government talking to you. Blah, blah, blah. Now, this will be a lot. If you think about it, it will be a lot. This is millions of messages that has to be delivered as fast as possible. Now, in this case, you can't send all the messages at once. Remember, I told you about rate limiting when we're talking about API. That if you call an API too much, it will stop answering you because it will be too much request. So, what do? What we do is we put this particular request into a queue. So, that queue means that all the requests can still go in, but everything will not be sent at once. So, it will be sent in batches till everything is finally done. So that message that the federal government is saying they want to send, eventually will probably get sent after an hour, but after an hour or 2 hours. But at the end of the day, the goal is that people get the message. But this will be in a queuing system. I don't know if that makes sense to you guys. Okay, I believe it makes sense. All right. We also have something called Kafka. Kafka is not a queue. Event-based architecture is not like a queuing system where you queue it into it. It's like a stream. Like, the reason I call it stream is the way the rivers of waters just go, right? Something like that. So instead of you queuing it, you put the information in a stream and then let everybody come and pick whatever they need, right? Something like that. That's what event-based architecture is. So you keep streaming the event, and then when whoever needs it, they can go there and say, okay, which one is my own? This is my own. Okay. So you stream the event with a streaming ID or a request ID. The person that requested the information from you, you stream it. And where does event streaming, where does it work? Say you are building a system that syncs data from a third party. For example, you have, let's say you have integration with Shopify, right? Your company has integration with Shopify, and then you are providing a service for businesses, like businesses, basically allowing them to do something. And then the customer says, I want a name, I want a list of all the I want you to give me a sheet of all the customers that have ever ordered from me. And then when you check, the customer has like, say, 200,000 customers. And that's a lot of money. That's a lot of records. So instead of putting that record at once, you can stream it in batches into a Kafka topic, and then easily the client can pick it up from there one after the other. It's a better solution than trying to call everything at once and then causing a deadlock in your DB. What we just explained right now. All right. This one you guys will have to read on your own, but I'll just explain it a bit. So usually when you want to build something, you give it to your developers and say, hey guys, I need your architectural diagram. Design the architecture for this particular feature. And then they give you the architectural diagram. So when you're looking at the architectural diagram, what should you look out for as a product manager? Let me show you an example. Sorry. I'm trying to look for one example. It's a particular name that is called where are you? Let's say for boots. Boots up. Why? So let's use this example. System design. So what should I look out for as a product manager? My people sent this to me and they say, okay, this is the architectural diagram. What I'm looking for is first thing I'm looking for is entry point. Every architecture diagram has an arrow that points the direction. As you can see, even though there's user A and user B, both of this arrow defines who started the conversation and who did not. As you can see, I hope you guys can see my screen. So you can see that this arrow is going up. So it shows that this user A is going into the chat system. And then probably after the chat system, they go into this group service, mapping, blah, blah, blah. They do all of this, right? They do all of this. And then after doing all of this, the chat system actually reply back, right? So this user, when the user chats the chat system up, the chat system collects all of this from them, collects the last seen message storage, store the message, they map the message, do everything. Immediately you message. So this gives you insight generally to how this system would work. So basically, anytime any of them, this guy messages, all of this service gets the information before replying back to the user B or simultaneously replying back. This does not look like a serious spec, actually. Let me look for one that is very serious that might scare you guys. WhatsApp system design. Let me use a WhatsApp system design. Okay, let me see. Maybe I can have. You see system designs that will make you want to right? Okay, so again, similarly, as you can see, client 1 and A enters after you always see direction. You always see direction. So look out for that direction and then look out for parts that doesn't have endings like this now, for example. It says asset service, saves and returns ID. What exactly is this? So you ask questions like that. What is this? I'm guessing this is a database, but then what is this? This is a streaming service. This is service, right? This is supposed to be a database. I don't know what exactly this is, but this is supposed to be a database. This is what we use to identify a database. It's a technical conversation, but you get to understand over time. So this is a streaming service. Okay, it goes here. Read receipt. Okay. After the read receipt in call, it just saves it. Okay, so if it just saves read receipt, how does this second user now get the read receipt? This diagram does not make sense because this information is not going back, right? So if client A sends a message, client B will never know that the message was sent. So again, this diagram is terrible. You see what we're basically trying to say, that the idea of every diagram, what question you as a product manager should ask is, where is the arrow leading and what am I basically expecting back in return? That's just what I wanted to explain. So you could check as many of them as possible. Let's look at this. Okay, client A, HTTP, okay, sends the request, or they use WebSocket, so there are two different designs. Blah, 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 blah. Also, this is also one way. So how does client B knows that the message is delivered? All the ones that we have been seeing does not cater for delivery receipts, which is very stupid, by the way. It just caters for one way message is sent, right? No delivery receipts. How do I know that this person has actually received my message? Like that acknowledgement. So again, this is how we're able to check our diagram, and there's no one rule fit all. There's no one rule that say, okay, this is how it should be, right? Aha, look at this one now. Look at this example now, right? This is a very good example, right? User A sends the request to user B. You can see how the data is moving from one place to another to one server. At the end of the day, it comes back to him, which is the way WhatsApp ecosystem actually works. So there's the delivery service. For example, let me see if the user is offline, blah, 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 blah. So this already sends DLRs. Yeah. So basically, just follow the arrow and then see if anything breaks. Usually, you would know that this is what I expect versus what they have drawn for me. If it is wrong, you can tell them, no, I don't want this. Yes, I want this, blah, blah, blah. What happens to this? At least ask clarification so that it gets better, right? You can be sure of what they would eventually implement for you. All right, so that's that about architectural diagram and backends and SQL. Like I said, this is just supposed to be like a general overview. So if you want to practice SQL online or learn more, like deeper knowledge, then you probably want to click this link too. It's a free platform. You can sign up, you can sign in, you can decide not to sign in safe and still just learn everything and get better at it. But it's an optional skill for us as product managers. If your company uses Metabase and you know how to do SQL, it will help you a lot. You don't have to go to your developers and start asking them, oh guys, how far now? Can you give me the data for this thing? Give me the data for this thing. You don't need to go and meet them. And let's assume your company cannot afford to buy what are they calling it? Cannot afford to pay for analytics tools and all that. You can also play. I have access to the database. As you can see, this is my database, Table Plus, right? I have access to my database, although it is not. It is only read only. I make sure that it's read only, so I don't go and update anything. But I have access to read data, so I can get data from the DB as much as I want, right? So I think it's a skill that every product manager should have, ideally, right? Please try to have the skill. All right, so because of time, I don't know if you guys are. Let me stop recording first.